Hello, welcome to the first video of semester 2. We're starting unit 6, the beginning of this semester today. The lesson is probability. This entire unit 6, is probability and statistics. So if you've got the notes out for yourself, you can follow along with me. This is the first time that the video has questions embedded into it. So hopefully you're paying attention, and when the question pops up on the screen, you'll be able to answer and get credit for having watched this video. Pretty short video if I do say so myself, I think. So let's do this. So what is probability? Probability, if you were to define it in words, is the number of favorable outcomes. Favorable meaning like, oh, that's the outcome that we want. We want to roll a 5 if we're talking about dice. We want to pick a hearts card, right? If we're talking about a deck of cards, right? It's the want that we have, right? And then, but there's all kinds of other outcomes. So probability is the number of favorable outcomes over the total number of possible outcomes. So a really easy example, right? There are 6 sides to a dice. So there are 6 possible outcomes when you roll it. But what's the probability of rolling an even one? Well, how many of them are even? 1, 2, 3, 4, 5, 6. So there are 3 even outcomes. Those are the favorable ones out of a total of 6. So that would be 3 over 6, which would reduce to a half, right? So the probability of rolling an even number on a dice is 50%. It's a half. So favorable meaning what we want, total meaning, well, total. So let's look at this situation with a spinner instead of a dice or a deck of cards. Larry spins a spinner 50 times. The spinner lands on orange 20 times, purple 5 times, green 10 times, and brown 15 times. What is the probability that Larry will land on orange? So what are the total number of spins? What are the total outcomes? There were 50 iterations of spinning. We spun this thing 50 times. So this is the total. So what is the probability that Larry will land on orange? Well, how many successful times did we land on orange? 20, right? So the probability of, actually, let me do it in orange because why not? The probability of spinning and landing on orange, well, the total number of favorable times that occurred was 20. We landed on orange 20 times out of a total of 50. So 20 over 50, which equals 2/5. Or if you plug that into a calculator, you get 0.4, right? Which you could also write as 40%. These all mean the same thing. Not trying to confuse you, but you may have heard of probability told to you in a fraction or a decimal or a percentage. I just want you to realize they all mean the same thing. 40% of the time means 2 out of 5 times. It's all the same. So favorable, we landed on it 20 times. Out of how many? We spun it 50 times. Let's do it again, real quick, real easy. The probability of landing on green or brown. Well, if we're landing on green, we landed on green how many times? 10 times. And we landed on brown how many times? 15 times. So how many favorable outcomes are there for landing on green or brown? Well, we're going to add the two together, right? If it's green or brown, they're both favorable. I'm going to combine their totals, right? It's not only green. It's not only brown. I don't care which one it is. So I've increased the favorable outcomes. We're going to add these two together. There are 25 favorable outcomes, green or brown. So the probability, I'm just going to stick with black here, of green or brown is there are 25 favorable outcomes out of the 50 spins, which just reduces to a half. Or you could say 0.5, or you could say 50%. Just be prepared for a question where it says, how likely is this to happen? Multiple choice, you can choose a percentage, or maybe it's going to ask you to type in a number, right? You would type in 0.5 here. I think probability is something that we're all pretty familiar with. What is the probability that Larry will land on purple and green? If you're imagining a spinner in your head, and here's purple and here's green, how can my spinner, as it spins around, land on purple or green? And green. How can it land on both? Okay, how about I insert a question right here? Can it land on both? And what does that mean the favorable outcomes are? So, boom, a question should be popping up on screen. It's going to be new to you. It's new to me to type such a question. Can it land on purple and green at the same time? And what does that make the probability? What does that make the favorable outcomes? Okay, so you've answered the question at this point already. It paused the video for you, at least it should have. It can't land on purple and green at the same time. So if that's literally impossible, how many favorable outcomes are there? 0. That is not possible. So the probability of purple and green is 0 out of 50. That never happened. That never can happen. So the probability is 0. We can't land on purple and green at the same time. That just doesn't make sense. So use a sentence to describe the makeup of the spinner. So if we're imagining, and let's not imagine, let's just draw it. If we've got this circle here, okay, I don't know why that didn't just make it a circle. Usually it does for me. There we go. That's much prettier. And, well, one thing that stood out to me here was that half the time we land on green and purple. So if I were to split this in half, 1/2 of the spinner should be, let me continue to use black actually, 1/2 of the spinner should be green and purple. Now, which is bigger, green or purple? Sorry, I said green or purple. 1/2 of the spinner should be green or black. So which is bigger, the green? Oh, it's, sorry, green or brown. So which is bigger, the green or the brown? Well, it landed on brown 15 times, whereas a green was only 10. So apparently brown must be taking up more of the spinner because it's more likely to land on that, right? I mean, imagine like a game, right? You go to an arcade and you have to like stop the spinner at like Chuck E. Cheese or Dave & Buster's and the big prize is always on the small sliver. That's because it's less likely to land on the tiny little space, right? So because we landed on brown more often, that space must be a little bit bigger, okay? So I'm going to say something like this, right? So, green is this much and brown is this much. Right? Does that make sense? And then we've got purple and orange left. Well, orange, we said, is 40% of the spinner. So this is half, right, on this side. So orange must be, nearly all of that. So something like this, right? This much is 40%, we'll say. And then purple, that tiny little sliver, is the remaining piece, right? Because we only landed on that 5 times, so it has to be the smallest of all of them, right? So we're kind of using deductive reasoning here. We're like, okay, I know that half of it has to be green or brown, so that's what I accomplished on the right half. And then the other half is mostly made up of orange, because that's 40%. And then purple is that remaining bit. Okay. Let's roll with another spinner, right? But we're changing the number of outcomes here. We have Martha spins a spinner 200 times, so that's our total. The spinner lands on letter A 62 times, letter B 33 times, the letter C 74 times, the letter D 11 times, and the letter E 20 times. Based on Martha's data, describe the makeup of the spinner by rounding. Okay, so let's describe the makeup. Approximately what part of the spinner does A and B make up? Well, if we landed on A and B 62 and 33 times, combine those together out of the 200 spins, right? The makeup of what we're doing here is we're saying that, if I land it on these two colors 50% of the time, well, then that means half of the spinner, physically speaking, right, is also those colors, right? I'm not going to land on two tiny pieces 50% of the time, right? I'm going to land on something that makes up the majority of the spinner, just like we did up here, right? We're doing a similar situation. We're just being a little more specific. We're going to use percentages here. So 62 plus 33, what is that? 95. And 95 out of 200 is approximately, plug that into a calculator, you'll see that you get, well, I'll plug it into a calculator on my end. 95 divided by 200 gets you 0.475. 0.475. So what we're going to call that is approximately 48%. Right? Because if you move the decimal twice, 1, 2, you could say 47.5%, but let's just do whole numbers, 48%. So 48% of the spinner is A and B, nearly half. Approximately what part of the spinner does letter C and E make up? C, 74, E, 20. 74 plus 20 out of the 200 spins. That's 94 out of 200. You plug that into a calculator. 94 divided by 200 is exactly 0.47. So that means it's exactly 47% of the spinner. So once again, nearly half of the spinner is C and E. Well, if nearly half is A and B, and nearly half is C and E, well, it makes sense that D is practically none of the spinner, right? Because we barely landed on D in comparison to all these other numbers. Right? So approximately what part of the spinner does B and E make up? 33 and 20. 53 out of 200. Plug that into a calculator, you get 0.265, which we'll call approximately 27% of the spinner. I'm doing the same thing over and over here, right? Combine all of those outcomes, the favorable outcomes, the one that we actually want. We want A and B. We want C and E. So add those events together. Those are the favorable outcomes and divide it by the total. We're just using that probability formula over and over and over. There are 5 white socks, 9 black socks, 3 blue socks, and 8 striped socks in a drawer. Find the probability that a sock randomly selected from the drawer is... What is the probability that the sock will be blue? Okay, before we get started here, we need to figure something out. And here, let's make this question number 2 of the video. What are the total possible outcomes here? Right, we need to know that. I was not handed that in this situation, right? In the beginning of this problem, they told me, hey, she spun the spinner 200 times, and that's it. That's the total. Hey, Larry spun the spinner 50 times. That's the total. But I'm just told I have a drawer full of socks. Take a minute here. 5 white socks, 9 black socks, 3 blue socks, 8 striped socks. What are my total number of possibilities? Question pops up on the screen now. Okay, so what'd you do to answer that question? I hope you got it right? I hope I didn't blow your mind with that, right? What are the total number of socks is what we want, right? 5 white socks, 9 black socks, 3 blue socks, and 8 striped socks. Apparently we're missing a couple of socks, right? The dryer ate it, right? Because we only have 5 white. That's not an even amount. So 5 plus 9 is 14, plus 3 is 17, plus 8 is 25. We have 25 total socks, okay? So what is the probability that the sock will be blue? So if I'm just putting my hand in the drawer and grabbing a sock at random, what is the probability that it will be blue? Well, there are only 3 blue socks out of the 25. Done. I'm just going to leave it as a fraction, right? I've been writing it as percentages, but you get the point, right? There are 3 blue socks out of the 25. What is the probability that the sock will be black or white? Well, again, there's a subtlety about or versus and, right, when it comes to determining probability, right? If you have and, you want to think about that closely, right? Like, what is the probability of doing this and this? Sometimes it's impossible. If I'm picking one sock, I can't pick a sock that's both striped and blue, right? At least, not in this situation, right? They must be, black stripes, not blue stripes, right? So, or, though, means you don't mind whether it's this or this. It's not that it has to be both. It's just that you're okay with it being, well, or this, right? There's a distinct difference between the word or and, okay? So, or just means one or the other. I don't mind. So we could have black, which is 9, or we could have white, which is 5 out of the 25. So that's 14 out of 25. That's the probability of picking black or white. What is the probability that it will not be striped? Don't get fooled by this, right? Not the probability that it'll be striped, right? This is the probability that it'll be striped. Okay? That's not what we want. Okay? Be careful. That's not what we want. Well, if that's the probability that it's striped, then everything else is not striped. So if 8 of them are striped, how many aren't striped? Well, there's 25 socks. So 25 minus 8 is 17. So 17 are not striped. And we got it. Hopefully that makes a lot of sense. And the last question. This video is literally going to be significantly under 20 minutes. And how about I toss one more question at you here? Let's see what we got. The Algebra 2 class took the statistics test last year and received the following scores. 15 students got A's, 23 got B's, 35 got C's, 19 got D's, 8 got F's. If this year we have 300 students, how many students should the Algebra 2 department expect to pass the test with at least A, B, or C? Okay, so I'm not going to ask you the same question here. They obviously didn't give us the total number of students from last year's test. We need to figure that out. So let's go ahead and add them all. 15 plus 23 plus 35 plus 19 plus 8 is, I did this ahead of time, it's 100. Okay, so 100 students took the test last year. Okay, that's a nice, pretty even number, 100. Nothing weird there. So if this year we have 300 students, how many students should the Algebra 2 department expect to pass with an A, B, or C? Well, in the past, what did we have? We had 15 with A's, 23 with B's, and 35 with C's out of the 100. So in the past, we had 23 plus 35 plus 15. I did it ahead of time. It's 73. So if 73 students passed out of 100, how many do we expect to pass out of 300? What do you think we should do? How about I pose that question right here, and I'll give you some multiple choice options. What of the options that I've provided you makes sense? Okay, so questions popping up now. Okay, so you answered it. If I'm trying to, basically the fancy word for it would be to extrapolate, right? If out of 100, 73 got it, well, how many would get it out of 200, right? Think about that, right? If 73 for every 100 students gets a passing grade, well, then the next 100 of students should also have 73 passing students, right? If the same result keeps happening, right? That's what we're assuming here with this probability, right? Is if out of 100 students, 73 get it right, well, then out of 200 students, that should be 73 times 2, right? Which is 146. So for every 100, we have 73 that pass. So if 300 students took the test, well, multiply by 3, right? 100 times 3 gives me 300, and 73 times 3 gives me 219. So for every 100, there's 73. If 100 students take the test, 73. How about another 100 students take it? Well, 73 are going to pass. So when we have 200 students, you just add them together. 146. Well, if another 100 students take it, well, guess what? 73 of them passed. So add those together, and we end up with 219. That's kind of what I'm imagining here. Does that make sense? Here's another way to think of it, and then the video's over. If 73 out of 100 did it, that's 73%. Well, what's 73% of 300? 0.73 times 300 is 219. That's another great way to think about it. Right? And maybe that's something you're more comfortable with, right? If you're a fan of percentages, then you might like that. All right, thanks for watching. Thanks for answering all those questions. We kept it at 20 minutes. Yeah, fantastic. Perfect. I'm about to record another one. So, I'll see you in a few. Peace.